Unit 3, Multiple Choice Form B, Answer Key. All right, number 1. At a large conference of teachers from a variety of subjects, a random sample of 50 mathematic teachers attending the conference was selected. Among the selected mathematics teachers, 28% had taken one or more courses in statistics. For which of the following populations is 28% a reasonable estimate of the percentage of those who have taken one or more courses in statistics? Okay, because I have had a random sample of teachers, I can generalize to the population of all teachers at that conference. So that's why it is B. The random sample is what allows us to generalize to where the sample was taken. So I have the population, and that's the conference, and I have all these little tiny samples within the population. And at any one point, if I use this sample, I can generalize to the entire population. Number 2, a recent study examined 609 car accidents in Toronto over a 14-month period. Records of phone services were used to determine whether the driver was using a cell phone during or immediately before the accident. Overall, the researchers found that drivers using a cell phone were 4.3 times as likely to have an accident than drivers that not. The result was statistically significant, which can be concluded. Well, notice I didn't have any random sample, and I didn't have any random assignment. So random sample, I didn't have a random sample, so I'm only able to make a conclusion to the people in the study. And no random assignment, so I'm only can do a association, but I cannot do causation. And so that describes B. The reason C is wrong, there's a correlation between cell phones and use of accident, but not necessarily an association. If there's a correlation, there's definitely an association. Correlation would indicate a linear association. So remember, if you have a correlation, you definitely have an association. But if you have an association, you don't necessarily have a correlation, because association just means as one goes up, the other goes up, as one goes down, the other goes down. And I could have an association that would look, like this. This would be an association, but not a correlation. This is a correlation because it's linear, but it's also an association. All right, number 3, for the purpose of determining the value of its end of the year inventory, a clothing store list at the end of each year every item currently in stock along with each tag item's wholesale price, which of the following is the best description of the end of year activity. All right, so notice what it does is it says every item. And every item, all of them, is the definition of census. Definitely not an experiment because I'm not doing anything to it. It's not any of these because it is the entire thing. A program exists to encourage more middle school students to major in math and science when they go to college. The organizers of the program want to estimate the proportion of students who, after completing the program, go into the major in math or science in college. The organizers will select a sample of students from the list of students of the completed program. Which of the following sampling methods best describes a stratified sample? So for stratified, we want separate strata, and then we will take a random sample within the strata. So select all, that would be just the females, and so it's not right. I would need males and females for this, and then I need a simple random sample, so that's not right. Randomly selects 50 students on the list. That's an SRS. So that's not stratified. Randomize the name on the list, then select every 10th. That's systematic. Randomly select 25 names from female students on the list and 25 names from male. So that is strata, female, male, and then 25, so forth. Randomly select 50 students on the list who are attending college. Again, that is also a simple random sample, and that's not what I'm looking for. Okay, number 5, a local TV station includes viewer survey questions about a current issue of the beginning of evening news broadcasts. Viewers are invited to social media to respond to the question. The result of the survey are shared with the audience at the end of each broadcast. In relation to the opinions and population of the region, which of the following is possible a reason the results have such surveys could be biased? Okay, so you can see that it's all of them by the answer, but let me talk through it. Viewers with strong opinions about the current issue are more likely to respond than viewers without. Yes, that would be true. The opinions of viewers of one television station are not necessarily represented by population. That's that of a region. That's true because just because it doesn't say it isn't, but not necessarily. So because I need a random sample from that population in order for me to be able to make a conclusion about that population of the reason. Viewers with access on social media are not necessarily representative of the population. Well, that's true. I mean, all of them are true. And because that's why you could see, well, this may be biased because of these different things, because of the way they ask us to do the survey. A recent poll of 1,500 random eligible voters, only 525 or 35% said that they did not vote in the last election. However, a vote count showed that 80% of eligible voters actually did not vote in the last election, which the following type is biased that mostly occurred. So notice at the poll, they said that they had only 35% claimed that they didn't vote, but actually in reality, 80% actually didn't vote. That's a big difference. And we're going to call that response bias, where the person didn't feel comfortable telling the truth because not voting is kind of shamed. You know, everybody talks about voting and you should exercise your right to vote. So if you don't vote, sometimes you don't want to tell people. A florist wanted to investigate whether a new powder added to the water of cut flowers helps keep the flowers fresh for longer than just water alone. For a shipment of roses that delivered to the store, the florist flipped a coin before placing the rose in its own individual container with the water. If the coin landed on heads, the rose was planted in the water with a new powder. Otherwise, the rose was planted in the water alone. What of the following is the best description of this method used by the florist? All right, so remember what I did here. I'm just going to talk about it and draw it out. So what I did is I have for shipment of roses delivered to the store, I flipped a coin before placing each rose. So I have this is my shipment. And essentially I'm putting them in group 1, group 2. And this gets treatment 1, and this gets treatment 2. And treatment 1 is the different water. Water, and then treated water. So you can see this is random assignment. And then we're going to compare results. So this is a completely randomized design because that's what's happening to it. It's not blocked. If it was blocked, it would be putting like, it would be doing this. Like, it would say, okay, block would be like this: red roses, white roses, or something like that. And then you'd go from here. You'd say, okay, treatment 1, treatment 2. Okay, and then compare the results. Non-observational study because it's definitely an experiment. It's not matched pairs because matched pairs would be where if you had rows 1 and rows 2, and rows 1 got the treatment 1 and rows 2 got the treatment 2. Anyway, that's matched pairs. The director of the fitness center wants to examine the effects of 2 exercise classes, spinning and aerobics, on body fat percentage. A 6-week spinning class and a 6-week aerobics class are offered at the same time and on the same days. so a person that can enroll in only one of them. A new class of each is about to begin, and each of the classes beginning at the end at the 6-week class. Use the change in body fat percentage as a response variable as conducting the test of the 1% level. The director will determine if there's a significant difference between the treatment means. Which of the following is a confounding variable of the study? The director's choice of spinning and aerobic classes as types of use in the study. I'm looking for the confounding variable, so I'm looking at the one that can affect both the explanatory and the response. And for response, I have, excuse me. So we have the director, we have 2 aerobics classes, and so we have spinning and we have aerobic. And we're looking for something that is going to affect both. And the random sample of 10, none of these other things affect both except this. If my choice is going to allow me to be excited about something because I have a choice in it, and potentially that would lead me to bias. To investigate whether the consumption of beet juice enhances exercise performance, the researchers selected a random sample of 50 student athletes at a college. The athletes in the sample were randomly assigned to one of 2 groups. So I'm going to do this. So group 1, group 2, random assignment. All right. In group 1, 25 athletes were given a daily dose of beetroot. And the other group, so I've got 25. So beetroot is placebo. And then I randomly assign it, so 25, and it says which results can be generalized. Well, where did I get these people? I have to look and see. I have a random sample of student athletes, so I had 50 random sample students. Because I have random sample, remember, there's my population, and I have lots and lots and lots of little samples. And if I randomly sample this, then I am able to generalize this to the population. A researcher wants to estimate the average money spent on extracurricular activities per school, certain region. This researcher randomly selects 20 people, 20 public schools and 20 private schools, okay, for use in the sample. Which of the following best describes the type of the sample that was taken? So I have 20 public, 20 private, and you put them in these groups here, and I have amount of money on extracurricular per school. The researcher wrote 20 public and 20 private for sample. So this is going to be the fact that these people are the same and these people are the same. That's going to be in a strata. And then I would go on to do an SRS of each strata. So it can't be anything else. It can't be, cluster sample would be a mix of a bunch of different people. Convenient sample, no. Simple random sample, no. So it has to be stratified, even though it didn't finish how to do the strata. And the last one, a survey was administered of high school students that claimed the certain state if parents thought the students' academic needs were being met. To select a sample, parents were divided into 2 groups. One group of parents lived in a population more than 100,000, and the other one was less than 100,000. A random sample of 100 parents. Okay, 100 parents, sorry. For each group was taken. Which of the a random sample of 100 parents from each group was taken. So I read that wrong. I thought it was doing this way, but it's okay. Which of the following statements about the sample of 200 parents is true? All right, so I did this. I said I'm definitely going to stratify this. So I'm going to take an SRS of 200 parents and SRS of 200 parents. And this definitely describes stratification, where each one is my strata. All right, thank you very much. I hope that helped.